I'm going to explain Coulomb's law, and I'm going to use two spheres, polystyrene spheres hanging from a thin string, and I'm going to say that we have charge Q1 and charge Q2. Now, Coulomb's law investigates the relationship between the force and the distance between the spheres. So I'm going to say let's work with distance R, and it also investigates the size of the charges. So what did Coulomb do? Coulomb firstly investigated the force between the spheres and the relationship with the force with one of the charges, and he found that it is actually a directly proportional relationship. That means that if you change the charge, the force will change in proportion. Therefore, if the charge doubles, the force will double. He also investigated the force relationship with the other charge. So if you would, for instance, half charge Q2, then the force would halve, the direct proportionality. He then investigated the relationship between force and the distance between the charges. Now, he did not find any relationship, a direct relationship between force and distance r, but he did find a relationship between force and the square of the distance. And what he found was that force is inversely proportional to the square of the distance. That means that you need to square whatever the amount that the distance is changing with, and there will be an inverse proportionality. If you, for example, double the distance between the charges, then it will be 1 over 2 squared, which is a quarter. Therefore, the force will change to a quarter of the original if the distance is doubled. In terms of graphs, if I plot a graph for the first relationship, force versus charge Q1, then the graph will look like this. So force versus Q1 must be a direct proportion, straight line. Next one, force versus Q2, direct. Next one, force versus 1 over r squared will be direct. That, of course, comes from if you had drawn a graph of force versus r squared, it would have been a hyperbola, because it is an inverse proportionality. So we confirm inverse proportionality by taking the reciprocal of one of the variables, and then you need to get a straight line. All of these graphs can now be combined in one. If you take the force versus the product of the two charges, since they are both directly proportional, it will be a straight line. If you combine all of them, you will get force versus Q1, Q2 over r squared, and r squared being in the denominator, therefore you will get a straight line. Now, whenever we get a straight line relationship in science, we are very happy about that, because that means that we can get a constant gradient. So if you then calculate the gradient from any 2 points on the graph, and it is straight line, so it will be constant, and in this case the gradient works out to be k, we call it gradient, is k, 9 times 10 to the power 9 is always going to be the gradient for investigations like this. Therefore, if you put this graph relationship in terms of the mathematical representation, it will be force directly proportional to Q1, Q2 over r squared. And if you convert this to an equation, it will be force equal to, now a proportionality must always be replaced with a proportionality constant, or we call it the gradient, which has got this fancy name of proportionality constant. So equal to k Q1 Q2 over r squared. And that is the relationship that Coulomb established, that force between two charges is directly proportional to the product of the charges and inversely proportional to the distance squared between the charges. Thank you.